Swayam Prabha. Digital India. Educated India.
Good morning. Welcome back to lecture number 20, part 1 on the topic storage design requirements. So, before seeing the product storage requirements, let me give a brief insight on the importance of this topic. It's a very, very important topic in the context of the subject, refrigeration and cold chain management. So, what are all the design consideration, what are all the requirements for cold store design? All these things would be discussed in this lecture, and in the subsequent lecture, I would be using ISHRE handbook. The data in the ISHRE handbook, most of the data are from ASHRE handbook. We'll be using that handbook to design the cold storage as per the industry standards. So the design would be a practical oriented approach, and the design of the cold storage for positive temperature applications, negative temperature applications, about 2 examples under each application. So that would be covered in the subsequent lecture. So when it comes to the product storage requirement, let us see the classification, how it is categorized, how the products are categorized into various classes. First one is class 1. Products that require very high relative humidity. Very high relative humidity. The relative humidity is expressed as percentage, whereas the specific humidity, which differs from the relative humidity, it is expressed in terms of kg of moisture per kg of dry air. So whichever the products which require very high relative humidity, in order to minimize the moisture and product weight loss during storage, these products are classified under class 1. Examples are cheese, butter, some of the dairy products, then eggs, vegetables, etc. And under class 2, products require relatively somewhat a moderate level of humidity, but not as very high humidity which is required for class 1 commodities. So the examples under this category class 2 are fruits and cut meats in retail stores. I would say since class 1 commodities require very high relative humidity, this may require high humidity, not very high. It's not moderate. Products which require moderate level of humidity are classified under class 3. So that is, class 3 is moderate relative. Examples, mushroom and watermelon. Under class 4 category of products which are not affected by humidity, like chocolates, candy, nuts, etc. It's not all candy. Some chocolates does not require a controlled environment. It can be even at our house, we used to keep some of the chocolates outside the refrigerator. But not all candy or chocolates can be kept outside the controlled environment. Some of them require a controlled environment. So, before seeing the storage design requirements, what are all the requirements that we need to consider, the factors that need to be considered while designing the storage? There is a if we see the importance of the cold storage, the need for the cold storage, primarily it is required to minimize the wastages, to extend the shelf life of the product, to improve, to maintain its quality, texture, taste, appearance, color, etc. And especially primary objective is to reduce the wastage. In our country, there is some lack of cold storage facilities or cold room infrastructure. It could be in the form of refrigerated trucks or refrigerated warehouses, or the cold rooms which are available at the local places. So there is a huge shortage, because of which lots of commodities are getting wasted, especially the fruits and vegetables get spoiled. There is a conception that especially the fruits and vegetables, the time at which it has got ripened, or it is available for the usage, the nutrients level in both the fruits and the vegetables are high, and it gets reduced if it is stored in a controlled environment. So there is always a thought among the people. So it is not like that. If a proper controlled environment is there, if these fruits and vegetables are stored, still there is a chance of maintaining the nutrients without losing the nutrients present in these fruits and vegetables and other commodities as well. So what is required is, there's a term called pre-cooling. There's a term called pre-cooling. Before seeing the term pre-cooling, so from the time harvest, from the harvest period till the time the product is available for consumption. That means it is readily available in the market for consumption. So from the harvest period to the consumption period, lots of nutrients are lost. So it doesn't mean that even though the fresh produced from the farm, it contains all the nutrients, because there is losses. So there's a term called pre-cooling. When I say, if proper mechanisms are used at the right time, like this pre-cooling is the removal of the heat at the field itself, which is the heat is produced due to the harvest. When the crop is harvested, when the crop is harvested and before it is transported in the form of a product to the market, or when it is available for the end user to consume. So if proper pre-cooling is employed at the field itself, so the lot of nutrients which would otherwise be lost could be retained, could be reduced or retained. So pre-cooling is the removal of heat at the field itself. If there is a delay of say 1 hour between the period of the harvest, and if there is a delay there is a delay of 1 hour in employing this pre-cooling technique. So what happens is the shelf life of the product gets reduced by about almost 1 day. It is about 18 to 20 hours. Then the shelf life, if there is a delay in 1 hour in the field in employing the pre-cooling technology, assuming that the ambient condition is around 35 degrees centigrade. If there is a delay of 1 hour, then the shelf life of the, when I say product, these products related to this horticulture commodities, then the shelf life of the horticulture commodities gets reduced by 20 to 24 hours, assuming the field temperature 35 degrees centigrade. 35 degrees centigrade. When the ambient conditions changes, then the reduction in the variation in the shelf life could be different. So I just want to give this insight before seeing the storage design requirements. First requirement is location of installation. That is the place of installation where the cold room has to be located, cold room or cold storage. How far the locality is from the main communication. What is the distance? How far it is from the main communication? Whether transport facilities are available at the location, at the site in which the cold room has to be developed, has to be established. So that is the first important one. Second thing is weather data information, gathering of weather data. What is the altitude of that particular location? Dry bulb temperature and wet bulb temperature. These are all very important properties of air. So dry bulb temperature is the temperature. So dry bulb temperature is the temperature measured by an ordinary thermometer. When we say the temperature of the air, it is, when we say the term temperature, it refers to the dry bulb temperature. How it differs from the wet bulb temperature? In the wet bulb temperature is temperature recorded by a thermometer whose bulb is covered with either with a wet cotton or a cloth. So what happens when we cover the thermometer bulb with a wet cloth? So what happens? The water which is present in that cloth, for the water to evaporate, evaporation requires heat. So heat is absorbed from the bulb and also the air which is surrounding the bulb. So because of which, when we measure the temperature, the wet bulb temperature, it will be less than the dry bulb temperature. So at the maximum, the wet bulb temperature and dry bulb temperature can be equal. So the wet bulb temperature cannot exceed the dry bulb temperature. The difference between the dry bulb temperature and the wet bulb temperature is called wet bulb depression. Depression. Let me write it here. So dry bulb temperature is dBT. Wet bulb temperature is WBT. So wet bulb depression is wet bulb is equal to dry bulb temperature minus wet bulb temperature. So that is the difference. So again, let me explain the wet bulb temperature once again. So it is the temperature recorded by a thermometer whose bulb is covered with a wet cloth. Suppose if the air is already humid, it cannot absorb more moisture. So if the air is less humid, then the amount of moisture or water vapor that can be absorbed by the air will be more. So accordingly, the wet bulb temperature will vary. So just to have an idea, this is the psychrometric chart which gives the various properties of the air. So here this is the dry bulb temperature. This is the dry bulb temperature. In case if the letters are not visible, I'll just write it. This is the dry bulb temperature in degrees centigrade. That is the x-axis. Y-axis is specific humidity. It is represented by the letter W. Its unit is kg per kg of dry air. And these lines are called the wet bulb temperature line. These lines are called wet bulb temperature lines. And the inclined curves are called relative humidity. These curves are called relative humidity. Which is expressed in terms of percentage. If we know any two properties of air, we can find out the remaining properties. Suppose if we know dry bulb temperature and specific humidity, we can find out relative humidity, wet bulb temperature, and this is called the saturation. This is the saturation curve. Saturation curve. Though this psychrometric chart may not be a direct content in this module, to have some basic idea about the properties of air, as it is a very important requirement while designing the cold storage. So I just thought of explaining the psychrometric chart for a few minutes. Okay, so to summarize, this is the x-axis is the dry bulb temperature, right? Y-axis. Here the y-axis is plotted on the right side. Normally in most of the charts or graphs, it will be left side. For the convenient purposes, it is taken on the right side. So specific humidity is expressed by the letter capital W. So that is in kg of moisture present in 1 kg of dry air. So that is the unit. And these inclined lines are called the wet bulb temperature lines. And this is the saturation curve. And the curves are called This curves represents the relative humidity of and it is expressed in terms of percentage. Of course, this is the enthalpy scale. This is the enthalpy. So this is in kilojoule per kg. When you are taking the properties of air in the design of cold storage, I will be using the psychrometric chart again. So if we know any two properties, as I said, we can find out the remaining properties. There is one more property that is called specific volume, which also can be found out from this chart. Now coming back to the storage design requirements, the third one is the infrastructure availability. Of course, the basic infrastructure facilities such as water availability, electricity should be there. Fourth one is the type of cold storage. Active, passive, whether it's an active one or a passive one. Small, medium, large. So this is according to the capacity, the storage capacity. It is classified into small, medium or large. Whether we want to have a medium type cold storage or a large type cold storage. Single or multi-commodity, whether the storage, cold storage, it will be used for storing a single commodity or a multi-commodity at different temperatures, etc. And here I would like to tell the difference between a cold room and a cold storage. Normally, cold room refers to a single room. Normally, the standard height is about 10 feet, which is about 3 meters. 3 meters. When we say cold storage, and a single room is normally it is used for, cold room is normally used for storing similar type of commodity or a single product, not multiple products. Suppose if you want to store multiple products, different products, then we need to go for a cold storage which has multiple cold rooms. It could be located in different floors, ground floor, first floor, etc. This is in continuation of the point which I have explained little ago. Type of the product to be stored, whether we want to store only one type of product in each room of the facility or different product. Whether we want to store one type of product or different product. Different products can be stored together only when the product is in a sealed container and the temperature matches. For example, we cannot mix two products whose storage temperatures are entirely different. Temperature and relative humidity. Different types of products have different temperature and relative humidity requirement, that is RH. Selecting the incorrect temperature. If you select the incorrect temperature, it can lead to reduced shelf life of the product. And reduced to, if appropriate storage temperature is not selected, then the shelf life of the product will be reduced. Point number 7, incoming temperature of the product. It is important to determine the temperature at which the product arrives at the facility to determine the cooling capacity. What is the temperature at which the product is entering the cold room? That will determine the cooling capacity. In the subsequent lectures, we will be designing the cold storage for different applications. What are all the loads? What are all the heat loads involved? In the next lecture, that is in lecture number 21, I think, we will be studying about the components of the heat load while designing the cold storage. Next point is quantity to be loaded. Product loading rate per chamber in kg or tons per day. Tons per day. How much quantity of the particular product is loaded into the cold room. Whether it's in terms of kilogram or tons per day. Density of the product, weight of the product per box, per pallet, number of pallets per level. It's like the stacking or the racking system. Number of racks per row, per column. Then insulation. What is the type of insulation which is used in the cold storage design? Thickness of the insulation. What is the material which is used? What is the thickness of the insulation material? This is required, so then only we will know the thermal conductivity value of the insulation material, which will be used in the design. Product loading methods, whether the product is loaded manually, that is with the help of human beings or labor, or is it loaded with the help of some mechanical equipment like fork or lift or conveyor, etc. Then the details of the door. What is the size of the door? That is the dimension of the door. Quantity. Frequency of the door openings per day. How many times the cold room door is opened and closed? What is the frequency? And how long it is kept open until it is closed. So what is the duration between the door opening and the door closing every time per day? And other details, external dimensions of the cold room, internal dimensions of the cold room, trolley height, what is the height of the trolley, rack dimensions, etc. How many racks are there in every row or every column, etc. What is the dimension of that rack? All these things. So if you see to summarize, if you look at the requirements of the storage design, there are about 13 points. There are 13 major factors are there. Location of the installation, weather data, infrastructure available, type, what is the type of cold storage, what is the type of product to be stored, temperature and relative humidity, what is the incoming temperature of the product that has to be stored, quantity to be loaded, density of the product, details about the insulation material, thickness of the insulation, details about the door, what is the size, how much time the door is kept open, and what is the duration between the opening and closing of the door, product loading method, whether it is done manually or with the use of some mechanical equipment, and the other details. So I will stop this part 1 of the lecture number 20 at this point. I will be continuing this lecture number 20 part 2 next. Thank you.